Number 1. Write equations in cylindrical coordinates.
Let's write that in cylindrical coordinates. So what should we do? How would you like to proceed? Do we see this 9x squared and plus 9y squared? Right? Should we put them together? Yeah. So now remember, keep this sixth equation here in mind when you convert back and forth Cartesian to cylindrical, cylindrical to Cartesian. Okay. Now when you see x squared plus y squared, then you can replace this by what? R squared. Yeah. And what about this x here? X here replaced by what? R cosine theta. Okay. And the z here, you just leave it as it is. Okay. So that will be the new equation. Okay. So you can put this way. Another way here, you can also isolate the z. So you can also put z squared equal to what? 9. Z squared equal to negative 9 r squared minus, adding 4 cosine theta and then plus 5. Now someone said, if we don't isolate the z squared to one side, would that be okay? That should be okay. Okay, it's the same equation. Okay. All right, so this is the first one. What about the second one? This is not in between here. This is not addition, right? But let's try this. Okay. How about we take out the common factor 5, and then we have x squared minus y squared. X is going to be replaced by what? R cosine theta, right? Y replaced by R sin theta. And what do we get? We get 5 R squared, right? This inside here will be what? Cosine squared minus sine squared, right? But that's not addition, right? You cannot replace this by 1, right? Because it's not addition. But does it remind you what formula? Trig formula. The double angle formula. Okay. What's the double angle formula? Okay. Cosine 2 theta equal to what? Cosine square theta minus sine square theta, but also equal to 1 minus 2 sine square theta, and also equal to 2 cosine square theta minus 1. Okay. So over here, this is the first one. Okay. Good. So according to the double angle formula, this is the cosine of 2 theta. So D equal to 5r squared cosine 2 theta. Question over here. I'm thinking if you leave like this, I think might still be marked correct. If you didn't use the double angle formula, it should be still correct. Okay? But it's better that you can realize this is actually cosine 2 theta. Okay, the next one. I'm going to use cylindrical coordinate to evaluate this triple integral. The E is a solid in the first octant. Okay, remember first octant. So in the first octant that lie under this paraboloid. Okay, under this paraboloid. All right, first octant. Okay, let me draw the picture here. Okay. So first octant, we only have. So you see that first octant, x, y, and z coordinate will all be positive. So the green I outlined over here. This is the part of the solid in the first octane. Okay, this is kind of like a slice of the a watermelon or something like this. Okay, so we try to find the triple integral of this x plus y plus z over this solid, the green one over here. Okay, let's describe this. Well, looking at this solid, okay, it is a D type. Okay, so bounded below by this surface, bounded above by this surface, and notice that the projection on the xy plane is a circular shape. So it makes us think about using cylindrical coordinates. And besides, this one over here has x squared plus y squared, right? Minus x squared plus y squared. So that will also confirm that cylindrical coordinate will be a better choice for this. Okay? Because whenever you see x squared plus y squared in this function, in the function that you integrate with, then cylindrical coordinate will be easy. Because what do we know about x squared plus y squared? What is it equal to? It's r squared, right? So therefore, we want to use cylindrical coordinate. Okay, let's describe this solid over here using cylindrical coordinates, r, theta, and z. Okay, which one would you like to start with? You want to start? Okay, let's just go by let's just do the z first. Okay, so z here is it's a z type, so it's bounded below by this xy plane, right? Z will equal to what? Equal to 0. Okay, so down over here, z will be equal to 0. Now, what about above? Above will be bounded by this paraboloid, right? So what does z equal to? Z equal to 9 minus x squared minus y squared, which is 9 minus what? R squared. Okay, you got it. So it is 9 minus R squared. All right, so that's for Z. Okay. Now let's think about the projection of the solid on the xy plane, right? It's a circular shape. So we think about R and theta. So theta is between what and what? 0 to power 2, because this is only in the first octave, right? It's not the whole circle. So it's 0 to power 2. Okay, finally, what about R? R goes from 0 to 3. Yeah. See the circle here? The radius is going to be 3. How do you know the radius is 3? Because this paraboloid intersect with the xy plane, so z will be equal to 0. So we set z equal to 0. You get this. Isolate x squared y squared, and then you get this equation. So the equation for this circle will be 3. So R will go from 0 to 3. Yeah, you got it. Good job. Now let's try to set up the integral then. Okay, let's write the integral. So that's equal to, so let's do the innermost integral first. Okay, so it will be x plus y plus okay, we'll do the integral. What happened to the x? We're going to replace x by what? X by r times cosine theta, right? So x will be this. Okay. What about y? We're going to replace by what? R times sine theta. Good. What about z? Z will stay the same. Okay, so we just add z. Good. Okay, and the dv we're going to replace by what? this is the rounding element, right? So it's going to replace by R, BZ, BR, B data. All right. D go from what to what? Well, we already figured this out, right? D over here go from 0 to 9 minus R squared. And then the later one is the other one. R go from 0 to 3. And data go from 0 to pi over 2. And that will be the integral. Okay. Question over here. So you have to think about I think sometimes the difficult part is to think about the upper and lower limit for the integration, right? But you have to express this solid like this. Okay? And the rest over here is just routine to do the integration. Okay? You try to evaluate this, and the solid is this one. That lies within this cylinder and above the plane Z equal to 0 and below this cone. You see the green highlighted part here is the solid. It's the cylinder, take away the cone. Okay, the cylinder above the xy plane and take away this cone over here. We try to evaluate this integral. Let's express this solid over here. Okay, it's a D-type solid bounded below by what? Bounded below by D equal to 0. So D will be right here, right? Bounded below by D equal to 0. So D greater equal to 0. And bounded above by what? By the surface of the cone, right? Is it right down over here? You see, if I draw a picture, okay. So then I have from this surface to this surface, right? So down here, D equals 0. Well, what about this? This is on the surface of the cone. The cone here is D squared equal to 9x squared plus 9y squared, which is the same as 9r squared, right? So D is going to be D squared equal to this. What does D equal to? Yes, 3r. Take the square root, right? So that will be 3r. So that is going to be 3r. So bounded above by 3r. Okay. All right, now let's look at the projection of this on the xy plane. It's a circular shape. And let's figure out the r and data, right? I'll go from what to what? I'll go from 0 to, for that circle, the radius is 3, right? Okay. So I'll go from 0 to 3. Yeah, you got it. 0 to 3. Now some people say, how do you know this circle here is that, right? Oh, it is actually it's given here. X squared plus y squared equals to 9. That's cylinder. So the circle, the radius here is 3. Okay. What about data? Data go from what to what? 0 to 2 pi. Yeah, the whole circle. Okay, so 0 to 2 pi. 0 to 2 pi. Okay, once you figure this R, data, and Z, the upper and lower limit, then you can write the triple integral here. Okay, so the triple integral here will be this is for the x squared. What is the x here replaced by? X is going to be replaced by what? R times cosine data, right? X replaced by this. And then you square this. And what do you replace the dv here by? dv R dz, dr, d data, right? Okay. So you're going to replace this value element by r, dz, dr, d data. Okay. Now you can put the upper and lower limit for z, r, and data. So we know that z go from 0 to 3r, right? Okay. And r go from 0 to 3. Yeah, you got it. And then data go from 0 to 2 pi. Yeah. Then we set up the integral. Okay. Now to do this type of integral, notice that over here, when you square this, right, then you will end up with r squared cosine squared data. Later on, this cosine squared data, when you integrate with respect to data at that time, then you have to think about using this half angle formula. Okay, you're going to express that using 1/2 times the quantity of 1 plus cosine 2 data. Okay. When you do this type of integral, a lot of times when you have sine square and cosine square, think about using the half angle formula to do it. Okay. Right. Question? All right, then number 4 here. Okay, number 4. We try to find the value of the solid that enclosed by this cone and the sphere over here. Okay. The sphere over here is this. Okay, so I have a picture. So it's kind of the green one here is the sphere. The cone is the red one, enclosed by the cone and the sphere. So it's this part right here. It's kind of like water, right? The drip of water here, like this drip of water here above the leaf over here. Think about like a bowl, okay? So inside this bowl over here. Okay. All right. So let's try to describe this solid here in terms of r, data, and z. Okay? It's a z type solid. Okay. Let's think about z. Z is bound. It's a competition. Okay, so Z is bounded below by the red surface, right? Okay, you see down here, right? It's bounded below by that surface. So the equation for that surface is Z equal to square root of x squared plus y squared. And when you see x squared plus y squared, you're going to replace that by what? Yeah, r squared. And the square root of r squared is this r, right? So that's equal to r. So Z equal to r. So down over here, this surface over here is Z equal to R, right? The wet one. So Z is bounded below by R, okay? And then above is bounded above by the sphere, the surface of the sphere, right? So the surface of the sphere has this equation. Let's relate that into that. So x squared plus y squared, we're going to replace it by R squared. So D squared equal to 50 minus R squared, right? So over here you will have D squared is equal to 50 minus R squared. We're going to consider only the positive Z. So Z is equal to positive square root of 50 minus R squared. So this solid is bounded above by the square root of 50 minus R squared. Okay, now once you figure this, I think the R and data will be easier. So we look at the projection of solid on the XY plane. It will be a circle, right? R go from what to what? So we have to find the intersection. We have to find the intersection of the cone with the sphere. How do you find the intersection of the cone with the sphere? If you solve the system equation, right? So for this one over here, so we're going to set, what do we have? Okay. So we're going to have d equal to square root of 50 minus r squared. And then the other one, we have d equal to r, right? We have these two equations. Solving these two equations, what do we get? Solve these two equations. You have r equal to square root of 50 minus r squared. So how do we solve this? Square both sides, right? R squared equal to 50 minus r squared. So 2r squared is equal to 50. R squared equal to 25. What does r equal to? 5, right? Okay. So solving these two equations, we find the intersecting circle there. It is going to be have r equal to 5, right? R equal to 5. So now we see that the r here go from 0 to 5. 0 to 5. Okay. What about data? Data go from what to? 0 to 2 pi, right? 0 to 2 pi. Now after this, we can write the triple integral for the value of the solid. Remember, to find the value of the solid, it's the triple integral of what? Triple integral 1, right? dv, integrate over the solid, right? So therefore, it will be the triple integral of 1. Okay. You don't need to put a 1 there. And the dv here we replace by what? R dz dr d data, right? Okay. And now we can put the upper and lower limit for dr and data. D go from r to square root of 50 minus r squared. R go from 0 to 5, right? And then data go from 0 to 2 pi. And then that's it, right? Okay, question. This one. Okay, let's finish the last one down, okay? Then when you do homework, this is actually homework problem. So we try together, okay? All right, so let's evaluate this integral by changing to the cylindrical coordinate. Let's describe the solid here using x, y, z first, right? So the inner integral here is integral with respect to z. So z going from square root of x squared plus y squared to 9. X go from negative square root of 64 minus y squared to positive 64 minus y squared. And then finally, the y here go from this constant negative 8 to 8. Now, if I use cylindrical coordinate, what would this be? Let's try to draw this. You see this x squared plus y squared over here? And when you take square root, this one here is just r. So d greater than equal to r, less than equal to 9. Okay? Well, what kind of surface is this? When d equals to this, okay, set d equal to this. Okay, let's draw the picture. So d equal to square root of x squared plus y squared. It is a cone, the green one over here. Okay. If you put that, you can also put d equal to r. Okay, for that. D equal to 9 is this horizontal plane right here. So D between this one and this one is this part of the cone. X is going to be between this one and this one. So this, if you set X equal to here, for this, say X equal to plus or minus square root of 64 minus y squared. If I square both sides, I will have x squared equal to this. Then we'll have x squared plus y squared equal to 64, right? Okay. This one here is actually the equation for this circle. That's because this is a projection of this on the xy plane. Okay. This is this. Okay. All right. And the y goes from negative 8 to 8. Okay. So y here goes from negative 8 to 8. Okay. Actually, I have a better picture on this. Okay. So you see that you project this onto the xy plane. It's going to be a circle. It's this blue circle over here. So this blue circle is this one. Okay. And the equation for the circle is x squared plus y squared equal to 64. Okay. X goes from this side to the other side. Y goes from negative 8 to 8. Okay. Now, can we express this using cylindrical coordinate? Okay, let's try this one first. Okay, let's start with the z. Z goes from what to what? Z goes R to 9. You got it. So it will be R to 9. Okay. Now let's look at the projection of the solid on the xy plane, which is a circle. So R goes from what to what? 0 to 8. Yeah. So R goes from 0 to 8. What about data? Data goes from 0 to 2 pi, right? And once you have this, I think you know how to set up how to do the integral, right? All right, so that's all for today.